My name is Sanya and I worked on Qiskit machine learning under the guidance of Alina. So in checkpoint 1, I talked about my motivation, which was to learn quantum machine learning. And I wanted to learn it by actually contributing to it. And I found this project and I thought it's perfect. So let's evaluate how it went. So this is sort of a roadmap of what I learned throughout the project and what Qiskit machine learning tutorials have to offer. So they basically solve classic machine learning problems like regression and classification using two different approaches, one of quantum neural networks and the other of Qiskit kernel machines. So in quantum neural networks, in tutorial 1, we explore their basics. In tutorial 2, we learn to use them to solve regression and classification problems on data sets that we have created on our own. In tutorial 2A, we try to go bigger and work on a real data set. And in tutorial 5, we make classical machine learning models using PyTorch and make a hybrid out of it by plugging these QNNs in them. The second approach that we follow is of Qiskit kernels. And in tutorial 3, the quantum kernels are introduced and we learn how to use them with models for classification and clustering. And in tutorial 7 and 8, we further deep down into two specific kernels like the Pegasus QSVC and the quantum kernel alignment. Apart from there, we have three other tutorials which are more advanced and they talk about QGAN, QCNN, and QAE. And in tutorial 9, we also learn to make a model, save it, and then reload it, and then train it again. So this is the basics of what the tutorials offer. Now let's see what I actually did. So I improved 8 of the tutorials. All of them are in different stages of review, with tutorial 3 being approved and merged. So my future goal is to actually work on all of them and get them all merged. Um, so while I was working on these tutorials, there was a constant back and forth of ideas and discussions with my mentors and other reviewers. And we formulated a general template that has been implemented on all the tutorials. So we've decided to actually divide the tutorial into 4 parts. And in the overview, we begin by telling what the tutorial covers. In introduction, we cover the basic concepts, give some theory and equations, and if we are following a reference paper, we mention about it. The content section is the real part where all the work gets done. And in conclusion, we sort of summarize all the key takeaways from that tutorial. And some of the points that we follow in the content is setting a seed for reproducibility so that whenever someone runs the tutorial, they can match their results. There was a big chunk of imports in the beginning. We have removed it and imported wherever necessary throughout the tutorial so that we can see for ourselves when to import and what is the use of that particular function. So there were cells which were really big as well. We have made them smaller so that when we run one cell, we can see a clear and interactive output to understand what new thing has happened by the running of this cell. And whenever we introduce a new term, we make sure that we explain something about it and give links on it so that it can be explored further. So our goal was to be clear, concise, and compelling. And I think we've done just that. So let's compare a before and after of one of the tutorials to see this for ourselves. So this is tutorial 7, with the right side being what it was and the left side, the opposite side being the one that has been updated. So you can see there are more graphs and more subsections explaining what is happening, and everything is more sort of interactive and easier to understand. So this was all. I really enjoyed learning, and the last few months have been great. It was a great learning opportunity, and I would like to thank my mentor and all the reviewers and the community for such a great experience. Thank you.